Hello everyone, welcome to the next lecture on the PY question series. Today we will discuss about improper integral. We will cover all those questions from the CSIR NET examination. Myself Dr. Harish Garg. You can simply follow my YouTube channel and the playlist is a CSIR UGC NET. The last two lecture was on the Riemann integration as well as bounded variation. Apart from them, you can also see there is a PY question of the various topics such as linear algebra, complex analysis, real analysis, statistics, and many more in this playlist. What is the objective is we will cover the 50 plus question in this lecture related to the improper integrals. We will take on all those questions from the CSIR NET, IIT JAM, GATE and NBHM examinations. All those questions which are come from the CSIR NET, we will cover the part B and the part C, both with the help of shortcut trick. Before we start with this PY question, let me firstly explain you how you can solve, how you can discuss the convergence or the divergence of this improper integral. So what is the rule behind that? I will explain you firstly with the help of these shortcut tricks, also with the help of these several examples. First of all, what is the meaning of this improper integral? Whenever you have the function, fine, or whenever the function is say 0 or infinity, whenever either a or b finite or it may has an infinite of this, then your first target is to find a singular point of fx. What is the meaning of the singular point of fx? Means you have to find all those values of the x such that f of x goes to the infinity. If this happens, then you can say this integration is called as a improper integration. If f of x is my finite for all the domain of a to b, then the integral is called as the convergent integral or called as the proper integration. Look at this. In this case, x is equal to 0. When x is equal to 0, it goes to the infinity. So this is the improper integral. Again for here, again for x is equal to 0 is the improper. Because of this integration is infinite, so this is an infinite or improper integration. Then how you can check the convergence or the divergence of this integration? There are the two rules. First rule is you can solve this integration and check whether this integration is finite or infinite. If this integration is my finite, if this is finite, then we call as the convergent. If this integration is infinite, we call as the divergent. But because it's not an easy target, you can solve each integration in a very simple manner. So I will tell you the simplest shortcut trick. First one is, type 1 is when you get a polynomial in your denominators. You can see here. Then whenever you get a polynomial, you can see 0 is the singular point, infinity is my singular point, b is my singular point, and a is my singular point. Look at that. When x is equal to a, the denominator goes to the 0. In this case, the denominator goes to the infinity, the denominator goes to the 0, denominator goes to the 0. And if you closely look about that, in this case the behavior of the convergence or divergence will be same. However, in this case the convergence is the opposite of these three cases. Now how you can see that? Whenever this first case happen, this will convergent when p is less than 1, and you can see in all these three cases the behavior are similar. Why? Because in each case the denominator goes to the 0, while in this case it is an infinity, so we can say the convergence is the opposite side. Now look at that. First of all, I can say this is nothing but my, because 0 is there, so what is the p? You can see p is my 3, which is greater than 1. So what is the meaning of that? It is a greater than 1 here. So that means it is a divergent. Now look at that. I can written this number as x of half, and half is less than 1. So it is a convergent. In this case, again the 0 is the point of discontinuity or the singular, and 2 is my greater than 1. So this is my divergent. Now in this case infinity will be there. So now since 3 over 2 is greater than 1, so this is my convergent. Always remember this simple rule. Whenever it goes to the 0, then you will get a convergence less than sign. Whenever it goes to the infinity, your convergence will be greater than sign, as you can see here. Now look at the second type. Whenever you will get the logarithm term, fine, whenever you will get the logarithm term, how you can solve that is again a very simple. Remember this rule. You can see in this case p is my 1. In this case, because it's x square, I can compare them with here. Now this will, what is the convergence? You can see infinity will be my point of discontinuity. Fine. So what is the rule for that? Whenever p is my greater than 1. So whenever p is my greater than 1, as I told you in the p test, whenever p is my greater than 1, it's a convergent, otherwise divergent. And you can see from here, what is the p? P is equal to 1. So this is my divergent. On the other hand, this is a more generalized formula. There is a p, q and r. So whenever p is my less than 1, p is my x raised to power p. Whenever it's a less than 1, it's always divergent. Whenever p is equal to 1, so that is like here, if I consider this is 1, then this q must be greater than 1 and r must be less than 1. In both the cases, you can see r needed to be less than of 1. So you can see, if I compare this case, p is my 2, q is my 1. So p is equal to 2, which is greater than 1, q is my greater than 1. So therefore this is my convergent. In this case, you can see I can compare this term by here. P is my greater than 1, p is 2, which is greater than 1. So it is also convergent. Third category, whenever you have the logarithm series, or you can say 0 to 1 log of x dx. Fine. Whenever you have to find this, it is a convergent or divergent whenever you can get this p is less than of q. And since this is opposite sign, so you can see it's a convergent whenever p is my greater, because it's a 0 is the point of discontinuity and it's a infinity is my in the denominator. So you can see this opposite sign. If I look about here, log of x dx, look at that. In the previous case, log is in the denominator, fine, but in this case log is in the numerator. Now if I say it's a 2 over 1, so 2 is greater than 1, so p is greater than of q, and you can see this is my convergent. It's a 0 to 1, I can return this is half, so 1 is less than 2 is again a convergent. How you can write this term? I can return this is 0 divided by anything. You can divide it by anything, and since 0 is always be less than the q, because I can return this is 0 upon 1, or you can return as a 0 over 2, or you can return as a 0 over 7. So 0 is always less than q, and 0 to 1, that is p is less than q, so it is convergent. However, if you take this, say 2 to infinity, then you can take it as a 0 over 4. So p is not greater than of q. So this is my divergent. This is the third type when logarithm in the numerator. Look at the another one. Now again this is the polynomial, but it is not as a single term. It is again a polynomial, but not as a single term. So then how you can do? Look at that. X is equal to 0 is the point of discontinuity only of this kind. So it means this is my finite. Fine. In this case, infinity. So this as well as this both. In this case, 0 is not there, infinity. So infinity is my point of discontinuity. In this case, 1 is the point of discontinuity. So I can expand this term as 1 minus x, 1 plus x square, and clearly says x is equal to 1 is only point of discontinuity of this kind. Now whenever there is a polynomial but consists of more than one term, always apply the limit comparison test. There are the two things. First one is, if you take f is less than g, if this g is my convergent, then f is my convergent. Remember, it's a very important tip for you. Whenever you take a less than sign, you always need a convergent here. On the other hand, if you prove f is greater than g, then this should be a divergent, then only this is a divergent. Always remember, when you consider a greater than sign, this value must be a divergent. Whenever you consider the less than sign, you always consider to be the convergent. This is my type 1. On the other hand, type 2 is, instead of taking the inequality sign, you can choose f and g, take the ratio and come out to be L. If, as I told you earlier, if because of this L, this is a convergent, then it is a convergent. And I can return this g is greater than f. So if it is a greater than, then this f is a divergent, then f g is my divergent. Fine. So if g is my divergent, so instead of this I can return as, if f is greater than g, if g is my divergent, then f is my divergent. Second case is, so I can skip this part. Now if you take the ratio, if L is my non-zero, then whatever the nature of this L is same of the L. But if it is 0, then you must be a convergent. If it is infinity, you must be divergent. So look at this one. Now if you look about this case, only 0 is the point of discontinuity. So if I take f is 1 over this complete portion, and g I can take as a 1 over x. So what is my f over g? F over g is my here. So clearly says when x approaches infinity, this goes to the 0. So once it goes to the 0, you need to be convergent. Is this convergent over the 0 to 1? It is a divergent by p test. It means you can never take 1 over x as a 1 over x as a gx. So in that case, because if it goes to the infinity, then it is fine. So for that case, you have to take g as, what is the highest power of this? I can take x and root x raised to power 3 by 2. Then what is f over g? If I take of this, it will be my x over x plus 3. So what is the limit as x approaches infinity? So as x approaches infinity, I can write this number as here. So this is my 1, which is non-zero. So whatever the g, so you can see from the 0 to 1, what is that? P is my 3 over 2, which is greater than 1. So it is my divergent. So therefore this is my divergent. Similarly, you can check about here, this and this for simple case. Look at the another one. If you have the beta function or the gamma function like of this, how you can write that? This is the gamma function of n plus 1. Whatever the power of this, you have to add them. If when it will be the convergent, if whatever you have written m and n both are my positive. Similarly for this case. Fine. So this is my convergent, because n in this case is 1 over 3 plus 1, which is 4 over 3 greater than 0. Now is the important thing about the sine x over sine or cosine. Whenever there is a 0 to infinity and here is a finite, this is always convergent. Fine. And but not absolutely. However, when you have some power of this, like of this and this from 0 to, it is convergent if this condition hold. Look at that. 3 is less than of 2 plus 1, not satisfied. Fine. So it means this is my divergent. For this case, 2 over 3 is less than of 2 plus 1, satisfied. This is my convergent. Instead of this, you can see here is 0 to infinity, only x, but we will take instead of 1 to infinity. Then this value is always convergent. Is always convergent whenever p is less than 2 and divergent when p is greater than or equal to 2. On the other hand, this is only convergent. But if you talk about the absolute convergent, then this 1 to infinity is convergent whenever p is greater than 1. And it's a conditional convergent, although it's a convergent, but conditional convergent whenever this inequality holds. Now you can see about here. So again, can I use this result for this case? No, because this result is only applicable when it's from 0 to pi by 2. But here is 0 to infinity. Fine. So you can't say that. This case you can see about here. This is the same case. P is my 3, which is greater than 2. So this is my divergent. On this case, it is my sine x. I can return this number as less than of 1 over this. I can return this number as x. Moreover, you can see 2 and 6 both will give you a finite. So it is my convergent. Fine. So this is my convergent. Now the last test is, we can use whenever there is a term of the sine and cosine, you can use as the Abel or the Dirichlet test. What is that? This rule is applicable only when you get the product of the two terms. If you prove the one term is a bounded and monotonic, second term integration of this is my convergent, then the Abel test suggested you the convergent. If any one of condition is not satisfied, then it is divergent. What is the Dirichlet test? Again, we have the same two condition, but on this G we have to prove it goes to the 0 as x approaches infinity. And f of x instead of the convergent, if it is a bounded, then we can say this product is a absolute convergent, otherwise not. Also, you can see how you can prove that. I can take the absolute convergent sine 4. I can say this number is always be less than of this number, and because of the integration 0 to infinity, you can see here both the terms are my point of discontinuities. So 0 and both. Fine. Remember, whenever 0 and infinity of fx, if both the points lower and upper both are my singular or discontinuous points, then this is always my divergent. Fine. If both are my singular points and the dissimilar points. Now look at these questions, how you can solve it. Find the area enclosed by of this. So that is 0 to infinity e raised to power minus 5 x raised to power 5. Firstly, we can check whether when it's a 0, it's a finite. When it's a infinity, it's again a finite. So you will get a finite. So it's a finite, it means this is my convergent. So which of the following is finite? First is the correct option. Since it consists of only one correct option, so A is my right answer. But look at the last option, minus 7 to 7, 1 over x raised to power 4. So clearly 0 is the point of singular. So I can break this number to be minus 7 to 0, 0 to 1 and 1 to 7. So you can see this case there is no problem, this case there is no problem, but for this case you can see from 0 to this x raised to power p is convergent when p is less than 1, but here this is greater than 1. So this means this is my divergent, the whole series is my divergent. Look at this case. Third case is minus 7 to infinity 1 over x raised to power 4. Again 0 is the point of discontinuity, so I can break them to be here. Again this is my divergent by the p test, so therefore this is also cancelled out. Now look at this second part. It's from minus infinity to plus infinity e raised to power minus 5 x raised to power 5 of dx. So clearly says infinity is not the point of discontinuity, so I can break to be here plus this. Now since you can see this case both will give you the finite answer. Fine. Now look at that. Whenever you take x is minus infinity, it will goes to the infinite. So this will goes to the infinite. So therefore this is my divergent. So whole series is my divergent. So the right answer is A is my correct answer. Look at this another one. For which of the following case is my here? Now firstly you can find the df. So e raised to power minus tx. What is the derivative of this? Minus minus plus of this case. So what is the integration of this case? This is lambda is outside, e raised to power of this. Now we all know what is the integration of this portion from 0 to this. This is the right answer of this problem. There is one more method. So if you are the student of the statistics, or you may know about the exponential distribution. If you look about that, what is that? This is the CDF of exponential distribution. So it means x follows my exponential distribution. Now what is that? This is e raised to power minus tx. What is the derivative of this? It is nothing but my PDF. Fine. 0 to infinity. In statistics, do you remember what is that? This is the MGF of minus of t. This is the MGF of, because what is the definition of the MGF? E raised to power tx fx. Fine, but here is minus of t. Now what is the MGF of the exponential distribution? MGF of this is my here. Now I can replace t to be the minus of t, so you will get the same answer as of this. So if you are remember the statistics, some distribution, then you can solve like this way. But if you are mathematics student, you can think about A is the right answer. Look at this another one. For alpha and beta the any real number, you can choose alpha is any real number, say 2. Okay, in each of the case, minus infinity mod x p of alpha. Now clearly says 0 is the point of infinity. Both are my singular points. Fine. In this case, both are my depending upon the value of the p alpha, because if p alpha is less than 1, then this part becomes, or if p alpha is less than 1, then this part becomes my infinite or 0. So whenever both, I can break this portion to be here. Now because both are my singular points, so this is my divergent. Remember, if both the lower and upper limits are my singular points, then it's a divergent. So he said it's a finite, less than infinite is finite. Wrong. This is wrong. This is wrong. This is the correct option. Fine. This is the first method. Second method is, you can also solve the same problem by some another method, like of the first case. I can choose alpha is my 2. You can choose p is also 2. Then your integration becomes mod x of 4. Mod x is always the positive number. So power 4 is always the positive number. Fine. Now what you could do, you can break them to be minus infinity to 0, 0 to 1, 1 to infinity. Fine. When you take this number, fine. Now what is that? It is divergent. Why? Because p is equal to 4 is greater than 1. For this case, it is convergent because p is equal to 4 is greater than 1. 1 is the divergent, second is that convergent, so whole series is my divergent. Similarly, for this case, you can again choose, if I choose alpha is 2, then p is my greater than half. I can again choose p is my 2. Again, it's a divergent. P is my less than of half. P any real number. So I can choose p is my say 0 because 0 is also the real number. So when p is 0, it is my 1 of dx. So clearly says it is infinite. So this option also cancelled. Only right option is D is the right answer. This improper integral has the point of discontinuity because the limits are my finite. So the discontinuity becomes when your fx will goes to the infinity. So your fx is my 2x when it will goes to the infinite, when x is 0 or x is half. So 0 and half are my point of discontinuity. Look at this another one. If in is given to be here, then the limit of this will be. Now what is the fx? What is my fx? It is not given to you. So you can take fx by own convenience. I can simply choose fx is my 1. Then your in will be 0 to infinity or 0 to pi by 2 sine of nx. What is the integration of this? Minus 1 over n cos nx, 0 to pi by 2. Minus 1 over n is outside. It's a cos n pi by 2. Cos 0 is a cos 0. Cos 0 is my 1. Fine. Now what will happen as n approaches infinity? So it's a when you n approach, what is the cos of infinity? This is my not defined. Fine. When as limit n approaches infinity. This is not defined. So what does it means? Limit n approaches infinity does not exist. Fine. So limit does not exist is the right answer. Remember, it's a very important concept because it is not defined at infinity. You can't say it's a infinity over infinity form because it is not defined, because it's a cos of infinity. You can't define the cos of infinity. So therefore limit does not exist. The integration of this, again a very simple, you can simply take the integration. You can see it's a cos x from 0 to infinity. So again cos infinity minus 1. What is that? Cos infinity does not exist. So this means this is, here rest options are, it means this is a divergent. Whenever it does not exist, we can say it's a divergent. A is the any positive real number so that which of the following are my convergent. Okay, we can apply the P test. A is any positive number, so I can choose A is my 1. So it's a 0 to 1, 1 over x4. Clearly say this is my divergent because P is my greater than 1. Whenever it's a 0 to 1, we need a less than 1. Okay, B. So first option is cancelled. Look at that. If I take this x of half, so clearly says P is my half, less than 1. So yes, this is a convergent. In this case, what is the power of P? P is my 1, which is divergent. Fine. In this case, P is equal to 2, which is greater than 1. So once it's greater than 1, it will be my convergent. So this is convergent. So this is my shortcut tips second, and this is my shortcut tips first. Which of the following series is again convergent? Fine. Now look at the first case. Root x plus 1. So what clearly says only 0 is the point of, 0 is the singular point. Fine. So I can simply take fx is my, it means I have to use the limit comparison test. So x plus 1 root x and gx, what I can do, because 0 is the only for this. So what is my f over g? If I divide them, it is my this. What is the limit as x approaches infinity? It goes to the 0. Now once it's a 0, we need g to be the convergent. Is this so? We can see what is the limit is 0 to 1. G is my, so clearly says because P is my half, which is less than 1. So G is my convergent, yes. Therefore F is convergent. So I can say is a convergent, the correct option. Look at this one. Root x, what is that? It's a 1. 1 is the point of discontinuity. Clearly says 1 is the point of discontinuity. Fine. So if I take x is divided by log x, and simply g I can take as a x. So what is the f over g? If I divide them, it is x root x over log x. So what is that? As a, it is 3 over 2. Now I can take the derivative, x of half into 1 by x. So clearly says it goes to the infinite. Once it is infinite, what is that? It is a divergent by P test. Because if it is infinity, we need g to be a divergent. So this is a divergent, f is divergent. Log x clearly says I can written this number as x raised to power 0 log of x power 1. So clearly says 1. When p is equal to greater than or equal to 1, it is divergent. So this is divergent. What is that? 1 minus cos of, what is the point of discontinuity? When it's a 0, cos 0 is 1. So 0 is the point of discontinuity. So once 0 is the point of discontinuity, I can take an as only x. So what is the f over g? If I take x over g is a 1 minus cos x. What is the limit as x approaches? So it's a infinity over what is that? It's undefined. So it will goes to the infinite. So once is infinity, this is a divergent. So therefore this is my divergent. only A is my correct answer of this problem. Which of the following series is not convergent? Okay, look at this first case. I can use the logarithm rule of this. So what is that? This is convergent. Why? Because 1 is less than 2, because say 0 to 1, it is a convergent. But we need a not. Look at the second rule. 2 to infinity, x raised to power 2 log x. What is that? Is it a convergent? Yes, it's a convergent. Why? Because p is equal to x raised to power p is my greater than 1, q is my 1. Fine. So this is also convergent. Look at this 0, 1 to infinity, sine x over x square. I can take the absolute value. Fine. This is less than or equal to this, and clearly says this is my convergent, because what is the limit of 1 to infinity? 1 over x square, p is equal to 2 greater than 1. So this is convergent. It means it is absolute convergent. Absolute convergent implies this is my convergent. So this is also convergent. So the right option is my D is the only right answer of this problem. Which of the following series is convergent? Now you have to check which of the following is convergent. So clearly says the first case. What is my P? 1. Is a 1, it's a divergent. Because we need convergent only because it's 0 to 1, because 0 is the only point of discontinuity. Look at the second case. P is equal to 2 greater than 1, but we need a convergent when it's a less than 1 from the 0 to 1. So this is not convergent, this is not convergent. What is that? This is x of half. Half is less than 1, it is convergent. 3 over 2 greater than 1, it is not convergent. So C is the right answer. Which of the following series is not convergent? Now look at the limits are my 1 to infinity. So what is the rule for this? Whenever p is greater than 1, we call as a convergent. P is less than equal to 1, we call as divergent. Half is less than 1, it is not convergent. Correct option is a divergent. 1 to p is greater than 1, wrong option. Half 3 by 2 is greater than 1, convergent. It is convergent. So we need a not convergent. A is my right answer. Okay, sine p. Okay, as I already told you, this will be a convergent only when p is my greater than 1. Fine. Otherwise, second method is because you need an absolute convergence. So I can start from sine x over this. This is less than of this number. Now you need a limits from 1 to infinity. So this is a convergent when, because infinity is the point of this. So when p is my strictly greater than 1. So when is here. Fine. Third method, you can also solve this by some examples like of this. If I simply take any counter example are this. So say, let's say p is equal to 0. Fine. For this case, when p is equal to 0, it's a x raised to power 0 is 1. So integration of sine x from 1 to infinity clearly says it is my cos infinity minus cos 1. This does not exist. So it means p is equal to 0 satisfied here, it is not. When p is equal to 1, it's a sine x over x. Fine. When you take this, it will be, so clearly says this, when you integrate from 1 to x, what is that? It is log of x. It is log of infinity does not exist. So it means p is equal to 1 is not satisfied. P is equal to 1 also not satisfied for this case. So it means it is satisfied only for the B. Otherwise, this is the simple shortcut tips as I told you earlier. You can write as directly. Okay, what is that? I already told you this is the tips whenever n is of less than of this. Whenever this rule is applicable only when the limits are by 0 to pi by 2. So this is the right answer. Otherwise, if you forget this rule, you can simply take n is my say 1, m is my 1. Fine, you can simply take. So what is the first option? This integration becomes my sine x over x. So clearly says 0 is not the point of discontinuity, pi by 2 is not the point of discontinuity. So this is my finite, because when you take 0, we all know limit this will be my 1 as x approach, that's a finite. Similarly, for pi by 2 is a finite, it means this is my convergent. So when n, so what is that? So 1 is greater than 2, not satisfied. 1 is greater than 0, satisfied. 1 is greater than 2, not satisfied. 1 less than 2, satisfied. So A and C options are cancelled out. Now for the other case, I can simply choose m is 0 and n is 1. M is 0, n is 1. So what is the integration of this? 0 to pi by 2, m is 0, sine is 1, or x. What is the answer of this? Is a log of x from 0 to pi by 2. Clearly says it's a log pi by 2 is finite, log 0 is infinite, so this will be my infinite. So that means this is not satisfied. So 1 is greater than of minus 1 is satisfied, but it's a divergent. This is divergent, but here you can see it's a convergent. So otherwise you can simply remember this rule. So D is the right answer. Or you may take any of the other example as well, like instead of this I can see m is 0, so 0 to pi by 2, 1 over x raised to power n. Since 0 is the only point of discontinuity, so this is convergent only when n is less than 1 by using the p test. But if you take m is 0 here, it will give you n is greater than minus 1. It means n can be 7, n can be 9, but it is not satisfied here. So therefore this is the only case when it's satisfied, all the cases. Okay, look at this one. So limits are, since infinity is my singular point, fine, so this value will be convergent when it is towards the infinity. So D is the right answer of this problem. Okay, function is defined to be here. Okay, consider the I1 is 0 to 1 x of half, and I2 is my 1 to infinity x of half. Then both exist and not. So you can see that this is convergent by p test. Why? Because p is less than 1. So this is convergent, implies the limit will exist. Is this convergent? Because it's a 1 to infinity, it is convergent only when p is greater than 1, but half is not greater than 1, so this is divergent. So it means I1 is existence, I2 does not. Both exist, cancel. I1 exists, I2 does not exist, rest options are cancelled. B is my right answer of the problem. Look at this another one. This is CSIR NET examination. So IP is my 1 to this T of P sine T of dt. Now 0, it depending upon the P, whether P is less than 1 or greater than 1. First of all, we can see about that. How you can say it's a convergent or divergent? Okay, whenever it's formed, I can write this form in terms of here, because I need 0 is the point of discontinuity. Now this becomes here, so this value I can written as 1 plus P. Fine. Now because this value will give the finite value for both the endpoints 0 and 1, the only discontinuity occurring based on this value. Now I can return this part as over T of 1 plus P minus. Fine, because only because of 0 is discontinuity here. Now I can check about this absolute convergent. Fine, sine T over T, this is a finite number, it is less than of minus 1 plus here it is from 0 to 1. Now as I told you, by using the p test, this will be convergent when this number will be less than 1, or 1 plus p should be greater than of minus 1, p should be greater than of minus 2. Now look at that, this is 0, this is minus 2, this is my convergent, otherwise divergent. Fine. Now p is equal to minus half lies here, this is a convergent series, so minus half here, so it is a convergent. Fine. Divergent for minus 3 by 2, minus 3 by 2 lies here, minus 1 point, but it's a convergent, but he said divergent, so this option is cancelled. IP is convergent for 4 by 3, 1.33 lies here, it's a convergent. Fine. Minus 4 by 3, minus 1.33 lies here, so it is a convergent, but he said divergent. This option is also cancelled. A and C are my right answer. Always remember, whenever there is a term of the sine, always written in this form whenever 0 is the point of discontinuity. Okay, which of the following is my bounded monotonic, bounded continuous, not defined, not continuous? Okay, I think it's very simple. First of all, we can check about the bounded. This cos of t x square plus t square. Fine. I can take here, this number should be less than of x square plus t square from 1 to infinity. Fine. This number is, what is that? What is the integration of this number? It's a tan inverse t over x, 1 over x from 1 to infinity. So what is that? It's a 1 over x pi over 2 minus tan inverse 1 over x, which is a finite number. Fine. Once is a finite number, but you can say it is my convergent. So if this is a finite number, mode of them is a finite, it means this is my bounded. Now second is, since x square plus t square is always greater than 0, fine, because the value of the t is from 1 to infinity, it is always greater than 0. Cos of t is a well defined function. Fine. This is a continuous function, this is a continuous function. So what is the meaning of that? Cos of t over x square plus t square is my well defined function, because this denominator will not be a 0, so it is not a well defined, cancelled. How you can prove it's a continuous or discontinuous? Okay, how you can prove continuity? Fine. How I can prove? Okay, I can simply use this Cauchy integral test. What is the Cauchy integral test? Integration of the fx over dx behaves same as of the series of fx or fn. Fine. Whatever the nature of this series, and the integration of this series will be always same. Now what is that? This is cos n divided by x square plus n square. Can you check the convergence of this? Because this is the series. How you can check about the series? By using the Mn test. Fine. So what you do? I can start with this modulus value x square plus n square, which is always be less than of x square plus n square, which is always be less than of 1 by n square, and clearly says this goes to the 0 as n approaches infinity. Fine. What does it mean? It means this is my convergent. Convergent is uniformly. What does it mean? This is my convergent uniformly. Once this is a convergent uniformly, it means this integration is my continuous as well as bounded, both. So it's a continuous. Bounded, we already proved that it's a continuous as well as bounded. So this is the way you can simply prove that of this part. Let a is my here, then derivative of this. So clearly says 0 is not the point of discontinuity, infinity is the only the singular point. So can you integrate this? It is my tan inverse t over 1 from this case. So what is that? Tan inverse infinity is pi by 2 is a 0. So value of a is my pi over 2. So log of a is cancelled, sine of a is my 1, correct. A is a rational number. Yes, a is pi by 2 is a rational number. Derivative of a is a 0, but it is not of this. So the right answers are B and D are the correct answers. Okay, look at this another one. What is the a? It is nothing but the beta function of this one. Fine. Then a is not a rational number. Okay, I can return this number. What is the beta function of mn, which is gamma function of the m, gamma function of the this divided by here. So I can return as n plus 1 divided by 2n plus 2. Then a is a rational or not? I can choose n is my 1. What is my a? Gamma function of 2, gamma function of 2, gamma function of 4. 1, 1, 4 is my 3 factorial, 1 over 6. So a is not a rational number, cancel out. I choose n is my 1, so this expression becomes my 1 over 4. 1 over 6 lies between them, satisfied. A is a natural number, wrong option. A inverse is my natural number, correct option. B and D are the right answers. Okay, look at this another one. None of them will be infinite because both are my finite, but we need a lower limit and the upper limit. Look at that. We need firstly as a 1, another is pi by 2. When it will be 1, so clearly says this number is always be less than of the 1 whenever x lies between 0 and 1. So the integration of 0 1 is here. What is that? L is less than 1. So A is the first correct option. Second is pi by 4. When it will be pi by 4? Because it will be pi by 4 only when I return is a tan inverse of 1. It means when it will be the tan inverse, if I replace this value to be x square. Fine. Now can you find the relation between this and this? Whenever x is lies between 0 and 1, choose x is half. So this value will be my 1 by 4. This value will be my 1 over 2 raised to power 8. Clearly says x raised to power 2 is greater than of this. Fine. Now I can add 1 on the both side. Fine. What is the reciprocal of this? It is less than of this. Fine. Now I can integrate over this 0 to 1. This part will be tan inverse x, 0 to 1. This number is my L. What will happen? This implies L is greater than of pi over 4. So this is the correct option. A and D are the correct options. Okay, look at this another one. An is come to be here. Okay, can you solve this integration? It is x raised to power minus 2 over minus 2 n plus 1 over n. So I can return 1 over 2n is a common. 2 minus I can adjust them. So it is a 1 over n square minus n plus 1 square. Or I can take it as LCM. Sorry, 1 over 2 is a common. 1 over 2 is a common. 2n plus 1 n square n plus 1 square. Now then if I take nc into an, what is the meaning of that? nc over 2 2n plus 1 over n square n plus 1 square. Then we need to take the limit as n approaches infinity. Okay, very simple. I can choose firstly c is equal to 3. So then the degree of the numerator becomes my 4. This is also 4. When n is equal to 3, this value and this value will be cancelled out. N over 2, 2n plus 1, n plus 1 square. Now the degree are same. Now you can divide this. So it is a 2 plus 1 over n, 1 plus 1 over n whole square. What is the limit? Limit will be 1. So when c is equal to 3, L will be my 1. So c is equal to 3, L is my 2 cancel. B is the right answer. whenever c is my greater than 3, fine, what is the numerator degree? You can choose c as say 4, then the numerator degree will be my 5, denominator degree will be 4. So what is the limit? Limit will goes to the infinity, because degree of numerator is greater than of degree of denominator. So whenever this, it goes to the 0 is the cancel out. Choose any number in between them. So say c is equal to 1, fine. What is the degree of numerator? It will be my, when n is 1, it will be my 2. What is the degree of denominator? It is my 4. So what is the limit? Is that limit will goes to the infinity. Sorry, limit will goes to the 0, because it's a denominator is larger, so it becomes infinity. 1 over infinity is 0, but he said infinity is a wrong option. Only correct option is my B is the right answer. Okay, look at this another one. This question I already explained you in the Riemann integrable function. Anyhow, first of all, you need to compute the fx. Take limit as n approaches infinity. What is my fx? When you take n approaches infinity, this value will goes to the 0, so it's my nothing. It's a 0 elsewhere. And whenever you take this, it is my like of this one, it is same function. Fine. Now what is that? Is a continuous function. This is my discontinuous function at x is equal to 0. Fine. Also at x is equal to 1. So this is a discontinuous function. Once it's a discontinuous function, it means it is not my uniform convergent. So once it's convergent, uniformly cancel out. Now what is the meaning of that? Since it is not continuous function, fine, what does it mean? It implies f is not Riemann integrable. As I already told you in the Riemann integrable lecture, if the function is not f is a f, because they are talking about the f is my here, f is not continuous, so it means it is not Riemann integrable. Now look at this integration 1. What is the fx is? This. Now when it will be convergent? It's a 0 to 1. 0 is the only point of singular, so it will be convergent when p is my less than 1. So C is the right answer, B is the right, so C is the correct option of this problem. Okay, look at this another one, which lies between of here. So I can return this function like of this, fine. Now again the degree of 2 is there. I can break this integration like of this 2 plus x square of cos 3x. Now clearly says this number is less than of cos is my 1. This number is also less than of the 1, because x square over 2 plus x square is always less than of the 1 or is equal to 1. So less than, and this is my x. So what is the upper limit of this? Integration of this will be my half. So upper limit is my 3, 1 over 2, 1. This is cancelled, this is cancelled, is the right answer. Or if you take the modulus, because cos is lies between -1 to +1, so I can return like of this case. So it's a minus half minus x, so minus half to plus half. Okay, which of the following is here? So again we can start from here. Sin x 1 plus x raised to power 8. What is the modulus value? It is always be less than of this number. Fine. Once it will be less than of this, how you can say about that? Then integration over, it is 10 to 19. So I can think about like 10 to 19 fx dx. Fine. Then what is that? Can you prove this number be less than of something? Can you prove? Now what is my fx? 1 over x raised to power 8, which is a decreasing function, plus it is a continuous function over this 10 to 19 domain. So what does it means? If it is decreasing function, what is the upper bound of this? Upper bound will be happening on the 10 lower limit, because it's a decreasing. So what is the value of this? 10 raised to power 8. Fine. Or you can say this number, I can written this number as 10 to 19 is also less than of x raised to power 8. Or if this is less than of 8, this is also there, this is also here. So I can substitute this value here. It is 19 1 over 10 raised to power 8 of dx. Now what is the answer of this? It's a constant. It's a 9 over 10 raised to power 8. So 9 over 10 raised to power 8. This option is cancelled out. I can return this number is less than of 9 is less than of the 10 of 10 raised to power 8. Equality strictly, that means 1 over 10 raised to power 7 is the right option of this problem. Look at this another one. What is that? It is nothing but beta function of m and n. When it will be convergent? When m is greater than 0, n is greater than 0. Equality doesn't exist when it will be here. So the right answer is D is my correct option. Okay, what is that? This is a gamma function of n plus 1. So that is a n. And it will be existence only when n is my positive. So it's a gamma function when n is my positive is the right answer. Okay, now this is another category. Always remember, whenever you give as a limit as n approaches infinity and summation form of f, say I over n, fine, say 1 over n as well, fine, you can convert this into f of x dx by substituting x is I over n, always. Fine, this is the question, and it's the most frequently question asked in the JM examination. Again, you can see it is of the form here, and 1 over n this is. So I can take x is k over n. I can change this integration to be, what is the dx? It is 1 over n into dk. So 1 over n, so pi is there, sine pi over 2 plus 5 pi over 2x. What is the limit? When x is equal to, when k is equal to 1, it's a 1 over n. As n approaches infinity, 0. When it's a n over n is my 1. Now you can see the integration will be easier. What is the integration of this part? Can you, or before the integration, sine of this will be by cos 5 pi by 2x. So what is the answer of this? If you integrate them, it's a pi sine 5 pi by 2x divided by 5 pi over 2. The limit is my 0 to 1. So it is my 2 over 5. What is that? Sine 5 pi by 2. Sine 0 is a 0. What is the sine 5 pi by 2? I can return this number as 2 pi plus pi by 2, which is sine pi by 2 is a 1. So the answer is 2 over pi. C is the right answer. Look at this another one. Again, this is a j over n is given to you, but you can't return this in the form of integration because limit n approaches infinity is not given to you anyway. Fine, limit is not given to you, then it is not be written here. N is greater than 1. I can choose n is my 2. Fine. So what is my t of f? It is 1 over 2. It's a f0. It's a f1 divided by 2. When n is 2, it's a 1. So summation will be only my f of 1 over 2. Now my target is to prove this number should be equal to the if 1 to 0 f of x dx. Now very simple. I can start from the first option. When n is my 2, the function becomes my 1 plus sine 4 pi x. Fine. I can substitute here. What is f0? Sine 0 is a 0. It's only 1. Sine 4 pi is a 0. Is here. Plus what is the f of half? It's a half. Sine of 2 pi is my this. What is the integration on this? It's a 1 plus sine 4 pi x. So it is a 1 plus 1 2. The left hand side is a 1. Right hand side is x plus cos minus cos 4 pi x over 4 pi. So over this. So when cos will be 0, 1 plus 0 minus 0. So 1 is 1, satisfied. First is the right answer. We can do for the second option. When you take 1 plus cos 2 pi nx. What is that? It is a half. Cos 0 is a 1. So 1 plus 1, 1 plus 1 is 2. F of 1, cos of 2 and pi. N is my 2. So I can return this is my 4 pi x. So cos 0 is 1. So 1 plus 1, 2. F1 is 1 plus 1, 2. What is the f of half? Is a 2 pi is again my here. What is that? It is my 2 plus 2, 4. Left hand side is my 2. This part will be 1 plus cos 4 pi x. What is the integration of this is? X plus sine 4 pi x over 4 pi. So clearly says this is a 1. When you take 1, 0, 0 is there. So 2 is not equal to 1. This option is cancelled out. Look at the third option. Sine square 2 and n is my 2. So I can return this as a 4 pi x. So what is the left hand side? So it's a half. F0 is a 0 over 2. F of half is a 0. Fine. But on the right hand side, how you integrate them? It's a 1 minus cos 8 pi x over 2. So clearly says it's a 0, but it is non-zero because of this value of half. So this option is also cancelled. Now look at the last option. Whether it's a cos square. So it is nothing but my cos square. N is my 2. So 2 plus 1, 3, 6 here. So what is my left hand side? Cos 0, 1, cos 1, 6 pi is a 1 over 2. Half is a half, 3 pi, cos square 3 pi 2 is my 1. Why? Always remember cos n pi is minus 1 raised to power n. On the left hand side, on the right hand side, it is 1 plus cos 12 pi x divided by 2. So what is that? It's a 1 plus, it's a 1. And I can integrate on the right hand side. What is that? It is a x plus cos 12 pi x over this over 0 to 1. So what is that? When it's a 1, cos 12 pi is a 1 over 2. When it's a 0, cos 0 is 1 over 2. It is my half. And this value becomes my, is it same? It is not same. So this option is also cancelled out. Right option is only A, because left hand side is only 1, right hand side is half. So this option is cancelled. Now look at this again. Limit n approaches infinity given and summation given. So because in this case 1 over n is not present. So I can multiply 1 over n. I can divide by 1 over n. Fine. Now I can return this number as 3 plus k over n. Now I can substitute x is my k over n. So dx will be 1 over n dk. So this number is 1 over 3 plus x. So what is the limit is 1 to n. When k is equal to 1 is as n approaches 0, it is 1. So what is the answer of this? Log of 3 plus, so what is that? Log of 4 minus log of 3. So log 4 over 3 is the right answer. Again this is there, but again the divided by n is not given. So I can divide and multiply by n by on. So it is my n square over k square plus n square. So I can return this number as k square over n square plus 1. Again take this, dx will be 1 over n dk. So it is 1 over x square plus 1. When k is equal to 0, x will be 0. When k is equal to n over n is my 1. What is the integration of this? Tan inverse x. So what is that? It is pi over 4 is the right answer of this problem. Again, this is the limit and the summation. So I need a 1 over n, rest I can return inside it. Cube 2n minus 1 and j is equal to 0. I can take x is j over n. So this is my x cube dx. What is the limit? When j is equal to 0 is this. When j is equal to 2n minus 1 over n. What is this limit? As n approaches infinity, this will goes to the 2. So what is the answer of this? x4 power 4. So what is that? 16 over 4. 4 is the right answer of the problem. Now look at this another one. Okay, that's a very interesting tip. You can solve this question within a 5 seconds. But remember my shortcut tricks. As I already told you, whenever f is a continuous function on the closed interval 0, 1, only on the 0, 1, such that either of these property hold, x raised to power n fx, answer is always 0. Remember, limit must be n approaches infinity. Whenever n is multiplied, then you have to find the value of f1. So I can look at that. I can open this bracket. I can written this part as xn ln of 1 plus x dx plus integration x raised to power n 1 plus x of dx. Now clearly says if I take the function is my ln of 1 plus x, which is a continuous on the 0, 1. So again the domain is my 0, 1. Then on this side it is the part of this, it is the f of 1. So what is the f of 1 is ln of 2 plus, because there is no n appears, so the answer will be 0. So what is the right answer of this? ln 2 plus 0 is ln 2 is the right answer. Again, it's a infinity. Remember, whenever it's a limit infinity and the summation, then you have to change into the integration. Whenever there is a limit infinity and the integration, you have to use these shortcut tricks. I can written this number as limit n approaches infinity, and I can take it as outside x raised to power n e of x square. Fine. So what is that? This is nothing but my fx. If you remember, this is the rule, xn of fx. So what is that? If it is n, it will be my f of 1. What is f of 1? E of 1 square is e of 1. So 2.718 is the right answer. Now it's a limit, it's an integration, but how you can solve that? Now because the limits is not 0 to 1, how you can solve? If you take x approaches 0, then this limit will be 0 to 0. Fine. It will be look like say this divided by x. X is my, so it's a 0 by 0 form. Whenever it's a 0 by 0 form, you have to apply the L'Hopital rule. So that means you have to take the derivative of this with respect to x and derivative of this. Denominator is easy. Fine. How you can take the derivative of this part? It's very simple. Firstly, substitute the value of 2x in t. So it is a 2x whole square into derivative of this. What is the derivative of this? Is 2 minus, substitute the lower limit at here, e raised to power 0 into derivative of 0, lower limit. So what is the right answer of this? It's a 0, sorry, it's a x. In the given statement, it is my x. So I can substitute here as x, and the derivative of this x is my 1. Then now you can see, now it is not an infinity 0 by 0 form. So now you can substitute it. Now you can, x is 0, e raised to power 0 is 1, e raised to power 0 is 1. So 2 minus 1 is 1. So its existence and is equal to 1 is the right answer. Look at this one. Again, if you take x approaches 3, 3 and 3, so it's a 0, it's a 0 by 0 form. So I can return this number as 1 plus t square divided by x minus 3. Then you can apply, because it's my 0 over 0 form, so you can apply the L'Hopital rule. Denominator is 1. In the numerator you can substitute this value at here, 1 plus x square into derivative of this 1 minus, you can substitute the lower limit at here, 1 plus 3 square into derivative of 3 is a 0. Now you can substitute the limit directly, 1 plus 9 into 1 minus 0, so e of 10. So you can see within a couple of seconds you can solve it in a easier manner. Look at this one. When x is 0, this part will be a 0. Is a 0, is a 0. Again it's a 0 by 0 form. So I can return this number as this, e of t square divided by 1 minus x square. Now you can take the limit as x approaches 0. So what is the denominator is minus e of x square into 2x. Now you have to apply the product rule. The first rule is here 0 to x e raised to power t square plus x of this one. So what is the derivative of this? I can substitute the upper limit at here into derivative of this minus, I can substitute the lower limit into derivative of this lower limit. Fine. Now what is that? Now again limit x approaches 0. Again it's a 0, but if you look, I can simplify it. Firstly it's 0 to infinity, 0 to x, this it will be my, this is a 0, it is my plus x e raised to power x square. I can return minus 2x e raised to power x square here, 2x e raised to power x square here. So you can see this number will be cancelled out. So it is a minus half here. Now again this portion will be my 0 by 0 form. Fine. Then what will happen, if this is again a 0 by 0 form, you can again apply the L'Hopital rule. So for the denominator side, x will be 1 e of x square plus 2x square e of x square. This is the denominator part. In the numerator part is e of x square, this value is 1 minus, if you substitute 0 into 0. Now what will happen, this, when you take limit as x approaches 0, this value will goes to the 0, this value will be 0, this value is 1, this value is only minus 2, minus half is minus 1 is the right answer of this problem. Look at this another one. It's again a 0 to 0, so it's again a 0 by 0 form. So I can again apply the L'Hopital rule. So what is the L'Hopital rule? Divided by, here is 2x, it is sine x into derivative of 1, derivative of x is 1, sine of 0 into derivative of 0 is 0. So what is that? Is a sine x over 2x as limit x approaches 0. What is that? It's a 1 over 2 is the right answer of the problem. Look at this another one. When it's a 0 positive, it's a 0, 0 to 0, again it's a 0. So it's x over 2 sine inverse t divided by sine square x. Now you can take its derivative. In the numerator part it's a sine inverse x, derivative of this, I can substitute x by 2 here, this is sine inverse x over 2 into 1 over 2. In the numerator part it's a 2 sine x into cos x, I can return this is cos of 2x. When you take x is equal to 0, what will happen? It's a sine 2x. It's a sine of 2x. Now again you can see it's a 0 by 0 form. I can again apply the L'Hopital rule. It is 1 over 1 minus x square into derivative of this, half is outside. What is that? It is 1 minus x square by 4 into derivative of x by 2. What is the derivative of this is 2 cos 2x. Now it is not 0 by 0 form. Then you can substitute x approaches 0 positive. So what is that? It's a 1 minus half 1 into half divided by cos 0 is 1. So what is that? 1 minus 1 over 4 over 2. So what is that? 4 minus 1, 3 over 8 is the right answer of the problem. Okay, look at this another one. F is a function with the continuous derivative such that this. Okay, again it's a 0 by 0 form, because when you take t is a 0, it's a x to x. So I can apply the L'Hopital rule. I can written firstly x minus t s f dash of s. So it's a 0 by 0 form. So what is the derivative of this? I can substitute x plus t f dash x plus t into derivative of here minus, I can substitute the below value, this f dash of x minus t, derivative with respect to t is my minus 1, because limit is with respect to t, divided by 2. Now it is not a 0 by 0 form, then you can apply the limit t approaches 0. It is a x f dash of x minus minus plus x f dash of x divided by 2. Left hand side is my fx. So fx will be my x f dash of x. Fine. So what does it mean? And your target is to find the f of 3. So what is my f of 3? F of 3 will be 3 times f dash of 3. So it's a 3 times of this. Now it can be 3 times. Okay. So how you can say that? F dash. So you need to find the f dash. It is just like say differential equation. F dash of this is my 1 over x. Fine. Now you can integrate this. What will happen? It is a log of fx. It is log of x plus log of constant. So what is the fx? Fx is cx. Fine. How you can find the value of c? As it is given that f of root 2 is my 2, I can substitute here is a 2 c of root 2. So c is my root 2. So I can substitute here f of x is my root 2 of x. Or what is the f of 3? Is a 3 root 2 is the right answer of the problem. Otherwise you can find that derivative value. What is the derivative value? C. C is my root 2. I can substitute here, which is again the same answer. Okay, look at this another one. What is the value of the pi by 4? Again pi by 4, 1 by root 2, 1 by root 2. There's the same answer, is a 0. Fine. Now you need to f dash. F of x is my cos x, is a sin x, e of t square. Fine. How you can find the derivative? Again the same rule. I can substitute the upper value is a cos square of x. Derivative of cos is minus sin x. Minus, I can substitute the lower limit is a sin square x into derivative of sin is cos x. Fine. Now this is the derivative. Now I can substitute pi by 4. Cos pi by 2, 4 is 1 by root 2 is 1 by square minus 1 by root 2. It's a minus 1 by 2 is a minus 1 by root 2. So it's a, what is that? Is it 0? Is it something? Sorry, it's a cos is positive. Fine, because 0 is not the answer. So I can take, what is that? It's a double of this, 2 times minus e of half. What is that? I can take root 2 and this is root e. So what is that? It's a minus root 2 by e. So minus, that is a b is my correct answer of this problem. So you can see it's a very simple, you can simplify it and you can get your answers. Okay, how you can derivative them? Again, e, I can substitute this value, it's a 4 sin square x, derivative of this is 2 cos x, minus, substitute the lower limit, it's a sine of 4x. Derivative of sine is a 2 sine x cos x. Now this is the value of the derivative. Now you can find at pi. So sine square pi is a 0, because what is the value of the sine pi is a 0. Cos is a -1. Sine pi is a 0. 2 sine of pi is a 0. Cos of pi is -1. So this value is a complete 0. It's minus of 2 is the right answer of this problem. Okay, look at this another one. It's again the CSIR NET examination. The improper integration. This y of minus half is a continuous, discontinuous. Okay, they are not talking about the convergent. So what is the integration of this? It is a root y over 1 over 2. Fine. What is that? It's a 2 times root x. Fine. Then this is a continuous, discontinuous. Okay, clearly says this is a continuous. Fine. So this is a discontinuous, cancel out. Now whether it's a continuous on the 0, clearly say it's a discontinuous at x is equal to 0 also, because there is no fraction component. So continuous in the closed interval as well. Okay. Now whenever there is a question of like this case, 1 over root 2 plus 1 over 4, the first way is you can rationalize it. Fine. But there is a very larger method. I will tell you the simplest shortcut trick. The answer of this is 1 over common difference. You can see this is a AP. Fine. 2, 4, 6 is a common difference is 2. So what is the right answer? What is the common difference is? 2 is the right answer of this problem. So B is my, whenever there is a consecutive term 2, 4, 4, 6, 6, 8 and so on, and limit n approaches infinity, right answer is 1 over common difference. Again you can see what is the right answer of this. What is the common difference is 3. So 1 over root 3 is the right answer of this problem. Look at this another one. F is a polynomial of this nature. It can be any real number such that a2 is a non-zero. What about the a0? What about the a1? It can be any real number. So I can assume a0 is, so that my calculation becomes okay. I can take this as a 0 as well. And because a2 is my non-zero, I can choose this as 1. So what is my fx? Fx is by simply x square. Fine. Now I can substitute the value of here. What is my e1? Integration of x square. What is that? It's a 2 over 3. What is the f of minus 1? It's a 1 plus 1. So what is that? It's a 2 over 3 minus 2 minus 4 over 3. What is the e2? I can substitute here. It's a 2 over 3. It's a half is outside. F of minus 1 is 1, 0, 1. So it's a 2 over 3 minus 1. It is minus 1 over 3. Now clearly says what is the value of e1? e1 is plus 4 over 3. e2 is my 1 over 3. Is it 4 by 3 less than 1 by 3? Wrong. e1 is twice of e2? Wrong. e1 is equal to 4 of this? Correct. e1, is it less than of the 8 by 3? Yes. So C and D are my correct options of this problem. Look at this another one. Again it is a similar of this. AIs can be any real numbers. So I can choose A0 is my 0, A1 is my 0, A2 is my non-zero. So A2 will be my 1. So what is my P of X? It is simply X square. So can you find the value of E1? What is that? It's a 2 over 3 minus half 0 plus 1. So it is a 2 over 3 minus half. It is 1 over 6. What is my E2? E2 will be, it's a 0 plus 1. So now it is my again 2 over 3. It is my 1 over 4. So it is 12, 8, 5 over 12 is the here. Fine. Now, okay, now I can return this is, okay, what is the mode of E1? I need, it's a 1 over 6, I can return as a 2 over 12. What is my E2? E2 is my 5 over 12. Fine. Now you can see about it. What is the right answer of this? E1 is greater than of E2. Wrong. E2 is greater than of, fine. Both are equal. Wrong. Is it a twice of this? Again wrong. So correct option is my B is the right answer of this problem. So this is the way you can solve all those improper integration in a very simple manner. We will see the next lecture on the complex analysis. Till then, you can simply scan and join my WhatsApp group for the various discussions. Like, share and comment on my videos. Best of luck, students. Happy learning.